let's talk about our family tree again, our lovely family tree. So today we're going to concentrate just on inverses. I've shown you how to get an inverse, right, algebraically. We've graphed our quadratic graphs, and we've graphed our square root graphs, and we've graphed our cubed root graphs, right? We've done all of that last week, this new unit. And now we're going to really concentrate on going back and forth from x squared to the square root of x, and x cubed and the cubed root of x, because they're inverses of each other. This one, right here, looks like this. And this one is just this shape turned on its side. Right? So when this one's turned on its side, it has two different parts to it. It has the positive part, which would be positive square root of x, and it has a negative part, negative square root of x. You only use one or the other. On this one, we use both sides of our parabola, right? It's a function, it's fine. But when it looks like this, it's either the positive part or the negative. We can't talk about both at the same time. Okay, let's look over at I should have done that in blue. That would have made me happier. That's okay. We'll do this one in blue or in red. All right, this one, my function looks like, I know what I want to say about this too. So I do want these blue. Bear with me, guys. You guys are awesome. And that needs to be blue. There we go. I'm happy now. All right, let's do this one in red. So this one looks like this. But then when we take the inverse of it, it looks like this. It's the same graph. How many of you, when you were graphing these, just turned your paper? 1, 2, to draw it. It's easier for me to draw these right here when I just turn my paper so it looks like that. I don't know why, but I just turn my paper. All right. And then when we're dealing with the negative one, it would be like this. Not easy. Okay. Okay. So there's some special points that we use when we graph x squared and the square root of x. One of them is wherever our vertex is. If it's the parent graph, it's at 0, 0. What's the next point I usually always go for? Not 2 yet. 1, 1, right? When I put in 1, I get 1. And what's the next one that I always put in? 2, and what do I get when I put in a 2? 4. I always get 2, 4. But when I'm graphing these, if it's the parent function, there's way too much talking going on. If it's the parent function, the first points I would graph would be, again, 0, 0, and then what? Think of graphing. You're graphing. I'm at 0, 0. What's the next point I would do on a square root? No. No. I'm at 0. 1, 1, right? The same as this one. Then if I'm at 1, 1, then what's the next one I do? 4, 2. Do you guys see that it's exactly the same? Hold on a second. 4, 2. It's exactly the same as this, only it's transposed. Okay, let's talk about when I'm graphing these. I always start at my origin if it's a parent graph, right? So my origin on this one would happen to be 0, 0. What's the next point I always go for? 1, 1, the same as on a square graph, right? And then what's the next one that always seems to happen? 2, 8. So when I'm doing these over here, what's the first one I'm always going for? 0, 0. What's the second one reference point I'm going for? 1, 1. What's the third one? 8, 2. It's right. They're transposed. Those are my magic numbers on these. Okay. Now you could just plug in. Well, we'll talk about that later. But as things shift, like for instance this one, as this one shifts over to up to, of course I'm not going to start at 0, 0. At this point I'm going to start at 2, 2, and I'm going to shift over 1 up 1, which would be 3, 3. Like you could discover that by plugging in the formula, or you can just find where your starting point is and count over 1 up 1, then over 4 up 2, right? Okay, I just want to show you this. It's really powerful to know both ways. Anybody can plug in numbers, but if you can see what the graph is supposed to do, that's what's most important. Okay? You need all eyes up here. Caps should be on pens. We're losing pens fast. We just opened a whole box on Thursday, and I've got like 10 markers that are dead. Okay. Let's do some whiteboard review. Can you guys graph this for me, please? No? What do you mean no? Graph that for me, please. Okay, so we're at about 50%, which I'm not too happy about, but we'll fix this. Okay, so H, or my horizontal shift, is going to be left 2. And K, my vertical shift, is going to be down 3. Okay? Same transformation that we've been dealing with for how long? No, not like all year. All year. The same thing over and over again. Okay? So I'm going to go over 2 and down 3. 1, 2, 3. There is my vertex. What's my magic first reference point? This is like my 0, 0. Over 1, up 1. And over what? 4. 1, 2, 3, 4, and up 2. Right? Or you can say I'm going to go over 1, up 1, and now I only have to go over 3 because I already went over 1, and then up 1 more. This length right here, this space between this dot and this point is always going to be the same. Do you see how it only rows 1? And from here it only rows 1? It always rises 1. Okay. Are you guys ready for something different? Hold on a second. Hold on. I'm going to try and use this. Y equals 4 times x plus 2. Only difference on this one now is going to be a scale factor. Okay, I'm doing the green one now. So I'm still over 2, down 3, but now I'm going to go over 1 and up 1, 2, 3, 4. It's got a scale factor of 4. And I'm going to go 3 more over for a total of 4 over. And then how much am I going to go up? Another 4, because this distance right here, right, the space in between the rate, see that change, is the same as this change. Okay? Is that making more sense? Sarah? There's too much talking behind me. It's always 3 apart, or 4. 1, 2, 3, 4.
Wait, it's always 4 for square root and it's for cube root 8, right?
It's 4 away from there. It's 4 away from that first reference point. That's why. Okay, hold on a second, guys. I need the talking to stop. I'll show you exactly why. Where are we right here? We're at -2, right? Where are we? Let's see. Here, if we were to go over 4, I need the talking to stop, guys. 1, 2, 3, 4, right? If I plug in -2, look what happens. I'm sorry, +2. What do I get? 4. I'm always going to keep getting those. Because, and the reason I pick that point is because it always gives me a nice, perfect square. And 8 minus 3 is 5. Is that where I'm at? Over 2 up 5. 1, 2, 3, 4, 5. Yes. It's always going to have the same shape. The first reference point is going to be over 1, up 1, unless there's a scale factor. It'll be up a little bit more. The second point that I always want to reference is always 4 away from there. And the reason it's 4 away is I chose it to be 4 away. You could choose it to be 6 away. Is that going to make your life easy? No. I could choose it to be 12 away. Is that going to make my life easy? What's the next simplest square root? 9. You want to make your magic point 9? Make it 9. That's going to give you, you could go over 9, and then you're going to have to go up 1, 2, 3 more times. Right? Yes. That's why you go over 8 for the cubic root, because the cube of 8 is 2. What's the next number you would go? What would be the next perfect cube? 27. You guys want to go over 27? I don't either. Right? So 8's the best one. Does that help a little bit clearing things up? So we have those magic numbers. We're working with 4s and we're working with 8s. Right? Okay, so let's go back. Let's erase all this because that's not the problem. The problem was this. So I know, but I want to have it on my presentation. Over 1, up 1, and then over 3 more, and over 1 more, or up 1 more. Okay, let's do the other side. Can you guys graph this one for me now? Please.
Yeah, sure.
Thank you. You're very welcome. Okay, let's do this one. See, guys, this is looking a lot better. So H, my horizontal, is going to be over to the right 1, right? Because the opposite of -1 is +1. And my vertical shift, or transformation, is going to be up 4. So I'm going to go over 1 and up 1, 2, 3, 4. And from that point, right? Freya, how much am I going to go over? 1, 1. Kayla, what am I going to do from here? Over 3 more. It's the same amount as I went up from this one. Up 1. So over 1, 2, 3, up 1.
Oh
I can't believe that you guys, the light bulb just went on for you. That's okay. I love it. Yes. Philip.
Whoa, okay.
Phil, hold on. I want to hear what Philip has to ask. What?
Tell me, if your scale factor was like 2.
Okay, if our scale factor was 2, can we pretend it's 2?
Yeah.
Can we put a 2 in front of it? Then how would this change, Philip?
From the first point, you go over 2, or over 1, up 2.
Up 2. Then what?
Then you go over 3, up 2.
Yes. Natasha. If I were to keep going, what would be my next point? You'd have to go over 5. Why would I go over 5?
Because it's 6 from your kid.
Natasha, why would I go over 5? Gets you to 9, and the square root of 9 is 3.
Wait, what did happen? What?
You guys get that? If I were to continue, so, whoa, you guys are like, okay. If I go over 1, the square root of 1 is 1, right? If I go over 4, it doesn't work really well with this here. Let's do this. let's forget about this. The scale, I don't want to confuse you with the scale factor. If I go over 1, I would go up 1, right? Because the square root of 1 is 1. If I go over 4, 1, 2, 3, 4, I'd have to go up 2 because the square root of 4 is 2. And if I go over 5 more, 1, 2, 3, 4, 5, right? And I would go up 3 because the square root of 9 is 3. What would be the next point I would go? 16.
Let's just move on so we can have time.
Yes.
Why go from 1 to 4?
It's okay. We're just going to stick with that. Okay, 3 reference points. Yes. How to get 9. Hold on, guys. From just the parent graph, y equals the absolute value of x. This is where I would start, right? Over 1, up 1. Next point would be 4. 1, 2, 3, 4, because the square root of 4 is 2. The next one would be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, because the square root of 9 is 3. I did it on the last one. I just picked it up and shifted it over 1. Okay? All right. Because I have this shift, guys, that fourth point wouldn't be at 9, it would be at 10, right? Because it's shifted over 1. I think we're starting to get it. Okay, let's keep going. Let's try this one. Can you guys graph this one for me, please? Too much chatter. You're not supposed to erase, right, guys? Okay, I'm going to go for it. So, on this one, I'm going to have a horizontal shift to the left 2, and I'm going to have a vertical shift of what? Nothing, right? 0. Okay, so if I go over 2, what's my magic numbers, my magic transformation numbers? On cubes, it's over 1, up 1, just like the square, and then over, not 4, over 2, up 8. Right? Because this is a cubic function, not a, guys, this is a cubic function, right? Not a cube root function. This is a cubic function. Because this is my parent graph, right? Do you really want to go over more than 2? If you cube 2, you get 8. If you decided you were going to go over 3, how far would we have to go up? 27. I don't want to go up 27, right? I only want to go over 2. Okay. Now we just have to do the other side of it. The other side of it is, it's symmetrical. It's over 1, down 1, and over 2, down 8. Okay, can you guys graph that one for me? All right, I think are we good? Thumbs up, thumbs down. Should we just go to cube roots? One more. Okay, do that one. Do that one. Okay, we're talking about accuracy, Sina, right? Okay, so I know I need, what's my horizontal shift, Sina? What's my horizontal shift? What? 1, which way? To the right or to the left? To the right, good. And what's my vertical shift? 5 what? Thank you. So I'm going to go over 1 and up 5. 1, 2, 3, 4, 5. My magic numbers are over 1, up 1, over 1, down 1, over 2, up 8. I can't really find that one. And over 2, down 8. Or if I already went over 1, down 1, I just need to go over 1 more and down how many? 7. 1, 2, 3, 4, 5, 6, 7. Whichever way you want to look at it. Right? Because we already went 1 and 1. You can say, I've already gone here, why would I go back and start over? You know what I mean? Or you can go back and start over. Totally up to you. Hold on, I can't hear this question. There's way too much side conversations going. Hold on. Yes. 8, exactly. All right. All right, let's keep going. Okay, so now these are cubic roots. Okay, so can you guys do, I think let's just do this one. I think we're doing good. Can you do that one for me? Fun. Okay, you guys are doing a fantastic job. So my horizontal shift is to the left 5, and my vertical shift is down 4. So we're going to go over 1, 2, 3, 4, 5, and down 1, 2, 3, 4. My magic numbers are 1, 1, and -1, -1. And then from this point, I can either go over 7, or from this point, I can go over 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go up how much? 2. 1, 2, 3, 4, 5. Okay, well, it's over here somewhere, and down. How pretty. All right, let's do some inverses. Inverses. Oh, let's talk about this first. Yes. I can't hear, guys. On every single one of these graphs, we're going over 8, up 2. Right? So since I was already over 1, I decided I was just going to go 7 more. If it confuses you, just stay right there at the vertex and go over 8, up 2. Okay? All right. Let's see. Let's go back and look at this. Okay, I've got 2 different graphs I'm going to graph for you here. So this one is a parent graph of x squared, which looks like this, only it's shifted to the right 2. So it goes over 2, and then my magic numbers are what? 1, 1, and 2 what? 4. 1, 2, 3, 4, and 2, 1, 2, 3, 4. There's my magic graph, right? The only way that graph is going to look different is if it had something in front of it, right? That's the only way. Then it's going to get even steeper because it's being multiplied by 4. It's got a scale factor of 4. Okay, so here's this one. This is the same graph, right? Only 2, 3, 4. This is the same graph, only we have different restrictions. This one says x greater than or equal to 2. Well, here's 2. Here's that line of 2. So I only want the part of the graph that's greater than this line. So that's which side? The right side or the left side? The right side. Everything greater than 2 is the right side. And this one is everything less than 2, which is the negative side. Oh, it broke up its little union. You can't do that. All right, so take a look at these and discuss with your group. All right, I want to go to this. Okay, inverses of squares and cubes. I think I'm going to do this. This is what I liked with last period. Okay, let's think about this. So, there we go. All right, so if we have y equals x squared, we have a plus and a minus side of our x squared, correct? We have the plus side, which is this, and we have the minus side, which is this. Isn't that pretty? Then we have y equals the square root of x. We actually have a plus and a minus of this as well. We have the minus that's down here, 1, 2, 3, 4. And we have the plus side that's up here. Only we don't talk about them both together. We talk about one or the other. This one we talk about all together, right? Because it's a function like this. It's a function, so we can write it all together, and we don't have to talk about domain and range. But on this one, it breaks it up. It says, look, you can only do one or the other. You can either have y equals the square root of x, or you have y equals the negative square root of x. But you can't have both together. Why can't you have both together? Then it won't be a function, right? I can't look at them both together because then it's not going to pass the test. So I either look at this one, either I look at the positive and make it a function, or I look at the negative and make it a function. Okay, does that clear some things up? Okay, so when we're talking about restricting the domain and range, what do you think this one's going to give us when I take the inverse of it? What do you think this graph right here, if I were to take the inverse of this right here, what graph is it going to give me? Is it going to be the top part, the positive part of the square root, or is it going to be the negative part of the square root? I think you guys need the visual.
No, the positive.
Right? If I was going to take the inverse,
Oh, so you're not flipping it over.
I do. I flip it over y equals x.
Oh.
Can you guys see it visually? If I take this point and I take its inverse, isn't its inverse, we can even just go by points, 2, 0, isn't that 0, 2? Right? And then our next point's going to be over 1, up 1. And my next point's going to be over 4, up 2. Now this one, if I take the inverse of 2, 0, it's going to be 0, 2. And then I'm going to go, this one is 1, 1, right? So don't I still go 1, 1? And then this one is 0, 1, 2, 3, 4, so it's going to be 4, 0, 1, 2, 3, 4. It's the negative side. So what I'm trying to show you guys is if you have the positive side of a parabola, you're going to get the positive side of the square root. If you have the negative side, then you're going to get the negative side of the square root. Okay, I think half of you are bored. Do you see it, Philip? My original part of my squared function, it's only the positive side of it. Do you see that? Originally I had this. Isn't this the positive side of it? Forget about the graph. Don't look at the graph. Which side is the positive side? The right side. So if I were to, I think you guys are getting hung up with actual values instead of thinking of it in terms of,
So you're just saying when you flip it over.
yes, when I take its inverse, when I take the inverse of that, if I do the inverse, it's going to look like this. Because it's the positive part of the inverse.
Oh, that's what we
Yeah. And so if I were to say, hey, I want to know what the inverse of this side is, then it's going to be this part, the negative part of it.
I was looking at it like this because like.
Okay? Better? That's kind of a pretty picture. So you know what I should do? Select all of it and center it. Look at that. That's all I'm going to do. Okay. All right, so we've already talked about, I think I'm going to skip over this. If you want to get this in your notes, feel free. I've got it on the board over here. There's only one thing I want to add to the board, and that's this. We have a positive square root function, looks like this, and a negative square root function looks like that, right? Okay. All right, this is the first thing I want you to do. I'm going to do one on my own, and then you guys are going to do one. Okay? I need eyes up here, pencils down, ears open. Sina, I need you to sit up. Do I have to ask you to look? Sydney, I need you to sit up. Tristan, I need you to sit up. Okay, everybody get into the position. Crisscross applesauce, come on. Come on, looking like an Algebra 2 class, guys. Parsa, I'm up here. I know, it's okay. All right, are we ready? All right, so I'm not going to grab, well, the first thing I'm going to look at is what shape should this look like? It's a parabola, right? But it says I only want to deal with the positive values. So when I get the inverse, it's going to be a positive square root, right? Okay. Now I could just take the points and figure it out, which I think I will. Let's do that first. I'm going to do those in green. This is your first homework question, so pay attention. Okay, so 0, 1, 2, 3, 4. So instead of going 0, 4, I'm going to go 4, 0. This is negative 4, though. I'm looking at it, I'm like, it shouldn't be over here. It should be negative 4, 0. So 1, 2, 3, 4. What's my next point? I don't even need to look at this anymore. Now I already know I've got my vertex. So what do? Up 1 over 1. I know that the scale factor is only 1 because this one's only 1. I don't even have to look at the equation at this point, right? I don't even need to look at it. 2. Now I need to go over what? What's the magic number? 4. 1, 2, 3, 4, and up 2. Does it look like it's an inverse? This is. How could we double check? What? Plugging in. Well, I can check to see if my graph is right by plugging in numbers or substituting in values, or I could transpose x's and y's to see if I'm right. So look at this one, 0, 2. So I should have another point at 2, 0, and I do. Okay, so now I'm going to do it algebraically. So in order to do it algebraically, we're going to transpose x and y. That's our first step. So instead of putting it in function notation, I'm going to take it out of function notation and make that y equals x squared minus 4. Now I'm going to transpose x and y. X equals y squared minus 4. Now I'm going to solve for y. First thing I'm going to do is I'm going to add 4 to both sides. And I'm left with x plus 4 equals y squared. Then take the square root of both sides. And I get y equals the square root of x plus 4. And now I'm going to put it back into function notation. The inverse function of g is the square root of x plus 4. I've already graphed it, but I know that should just shift over 4, right? And then it's a normal function. So this is what we're doing today for homework. You're going to have to graph the regular function, given some type of restriction if there is one, and then you're going to have to algebraically find the inverse, and then go back and graph it to check. It's almost like a check. Now, I don't care if you do this first and then this, or this and then that, but you got to have both pieces of it. Let's look at a different one. Let's see, number 2, number 3. Okay, this is going in reverse. Now, I don't need any restrictions here because there's already a restriction, because it's a square root function. So this is going to result in what type of shape once I take the inverse of this function? What's the shape going to be? It's going to be a parabola, right? And it's going to be the positive side of the parabola, right? You should just be able to see that. Since this is the positive side of a square root function, if I take the inverse, it's going to be the positive side of a parabola or a quadratic function. So I'm going to do this one in transpose x and y. So I'm going to take it out of function notation and say y equals the square root of x plus 1. Transpose x and y. Isolate my y by subtracting 1 first. And then squaring both sides. And I get y equals x minus 1 squared. Only when we go over to 1, we're going to have to, x is going to have to be greater than or equal to negative 1. Sorry, positive 1. Because when I graph this, going over to graph, I'm shifting over 1. I go over 1, up 1. I don't need to go over, I'll do it just in case. Then over 2, 1, 2, 3, 4. Graphing, graphing. Do you guys see? I can't have both sides of that, right? Because my original didn't have 2 sides. So I've got to erase the negative side. And when I erase that negative side, that means that all my values have to be greater than negative 1. It should have been negative 1. I was right the first time. Right? I'm talking about this graph, but only the values that are greater than negative 1, because I want only the positive side. Did I screw up? So I did the math in my head right here and then graphed it wrong and then second-guessed myself? Is that what I did? Okay. All right. Just so we know and caught my mistake of exactly what I did. Thank you, Kellen. I appreciate it. No wonder I had these looks like, huh? What is she doing? Okay. So we should have gone over 1. Oh, look it. That makes sense because it's over that line right there, right? Over 1, up 1, over 2, up 4. Yeah, I did that on purpose. Right? Okay. I'm amazing at making mistakes, right? Yes, so you can catch them. I'm shifting over 1. Tell him. Yes. On your homework, this one, maybe we don't. Yes, we do. So you're also going to be able to go from a cubic function to a cube root, and then you'll have cube roots going to cubic functions. And we won't have restrictions on these, right? Because both of them back and forth are functions, right? This is a function. This is a function. There's no restrictions at all. All right, I'm going to pass out your homework, and what I want you guys to do is get started on, I want you to draw your lines and draw your graphs of the original function. So everything, let's put it back on, which one do you guys want? This one? Yeah? Okay. Sure. Thank you. Oh, you do this, I'll do this. I always start on that side. Here we go. There we go. I think we're done. I don't need to record anymore.